Hi, and welcome back to the PMBOK 5th edition. This module covers the Project Cost Management knowledge area. The main objective is to complete the project on budget. However, it's not that easy to do. It requires that the project team conduct planning, estimating, budgeting, financing, funding, managing, and controlling costs so that the project can be completed within the approved budget. Remember in time management when we identified all those tasks and activities that need to take place on the project? Well, in cost management, we take those tasks and activities and determine the cost of the resources, labor, materials, equipment, and supplies needed to complete each of them. Note that we must always consider the impact to cost when making decisions on the project, such as adding more resources, which might put us back on the schedule, but increase cost. With that in mind, let's take a look at the 3 cost-related processes: plan cost management, estimate costs, determine budget, and control costs. So, beginning with the next video, I'll walk you through each of these processes. Before we cover the first process in the project cost management knowledge area, I'd like you to note that these processes interact with each other as well as with processes in other knowledge areas. On some projects, for instance, especially those of a smaller scope, cost estimating and cost budgeting are tightly linked and can be viewed as a single process that can be performed by a single person over a relatively short period of time. PMBOK lays these processes out separately because each has a different set of tools and techniques. So with the integrated nature of these processes in mind, let's look at the first process, plan cost management, which establishes the policies, procedures, and documentation for planning, managing, expending, and controlling project costs. Some key inputs we use in this process are the project management plan, which includes the scope baseline. Remember that the scope baseline includes the project scope statement, WBS, and WBS dictionary. Another input is the schedule baseline, which defines the nature of the project and when project costs will be incurred. Also, the project charter is needed because it provides a budget summary from which the detailed costs on the project are developed. Some of the key tools and techniques for the plan cost management process include expert judgment, which provides valuable insight about the environment of the project and how we can look at and manage costs. Analytical techniques such as NPV, IRR, ROI, and payback period are often useful on projects, such as in the case where we want to know how long it will take to recover our money should we invest in a project. The payback period will tell us a specific time period in which we will recover our initial investment, and we can use this information to decide whether we should accept or reject the project based on the criteria of when we need to be paid back. Planning meetings are valuable in that we can leverage the knowledge and expertise of the project team to develop the cost management plan. The single desired output of this process is the cost management plan. Remember that the cost management plan is part of the overall project management plan and describes how project costs will be planned, structured, and controlled throughout the project. It's really a strategy document that will include but not limited to units of measure, levels of precision and accuracy, organizational procedures, control thresholds, and rules for performance measurement. It will also outline the format and frequency for the various cost reports that will be made available to various stakeholders. The second process is estimate costs. It's the process of developing an approximation of the monetary resources needed to complete all project activities. For each activity, we should identify any and all associated costs for labor, materials, equipment, services, and facilities, as well as special categories such as inflation allowance, cost of financing, and contingency costs. Cost estimates are a prediction based on the information known at a given point in time. This prediction includes the identification and consideration of costing alternatives to initiate and complete the project. As you go throughout the project, cost estimates should be reviewed and refined as additional details are gathered and assumptions are tested. Also, we should identify and consider cost alternatives and trade-offs, as well as risks on the project such as make versus buy versus lease, and the sharing of resources in order to achieve optimal costs for the project. Project estimates tend to become more accurate as the project progresses throughout the project lifecycle. For example, a project in the initiation phase may have a rough order of magnitude, often referred to as ROM estimate, in the range of -25% to +75%. During the planning phase, budget estimates can narrow the range of accuracy to -10% to +25%. Later in the project, during final user acceptance testing, you are much more confident in your estimate, so you create a definitive estimate, and the accuracy level should range from -5% to +10%. So, as you gather more information and become more involved in the project details, your estimates become more definite. The key inputs include the cost management plan, which defines how project costs will be managed and controlled on the project, and the level of accuracy required to estimate activity costs. This process also requires the human resource management plan that provides project staffing requirements and personnel rates, which are necessary components for developing the project cost estimates. The scope baseline is also an input, and remember, this includes the scope statement, WBS, and WBS dictionary. Two final inputs to review here: the project schedule and risk register. The project schedule will indicate the type and quantity of resources and the amount of time which those resources are applied to complete the work of the project. These are important factors in determining the project cost. The risk register will also be helpful since it will show all the risks, particularly the ones we view as threats or opportunities, and any associated risk response costs. The estimate cost process has quite a list of tools and techniques, as you can see here. The first is expert judgment, as we can and should take advantage of any knowledge we have gained in prior projects and apply it in this process. This could include methods of estimating costs and how to reconcile differences between them. With analogous estimating, we use the actual cost of a previous similar project as the basis for estimating the cost of the current project. Obviously, this approach is less costly and less time-consuming, but it is also generally less accurate. It tends to be more reliable when the previous projects are similar in fact and not just in appearance. It's often used for an initial estimate at the beginning of the project when little information is available. Let's review parametric estimating, which involves using a statistical relationship between historical data and other variables in unit value form to calculate cost estimates. For example, in a previous project, it cost $100 to develop one web page, so it will cost $400 to develop 4 web pages. When you hear the word parametric, I want you to think of mathematical calculations. Detailed costs are then summarized or rolled up to higher levels for subsequent reporting and tracking purposes. 3-point estimating can be beneficial in that it can help to improve the accuracy of activity cost estimates by using 3 values to define an approximate range for an activity's cost. The idea is to come up with an expected cost estimate using a weighted average of 3 estimates, namely pessimistic, most likely, and optimistic. Bottom-up estimating involves estimating the cost of individual work packages or individual schedule activities with the greatest level of specified detail. Reserve analysis is a tool and technique here because sometimes we may have to establish cost reserves for unknown situations. There are 2 types, including contingency reserves and management reserves. Contingency reserves are reserves attributed to identified project risks that you know will occur, also referred to as known unknowns, in other words, accepted risks. For example, you may have a contingency reserve for project staff lacking skills in a certain technology you're implementing. Note that contingency reserves are part of the cost performance baseline. Management reserves are for risks that have not been identified, also referred to as unknown unknowns. Unfortunately, most projects are hit by unidentified risks, so management reserves serve as a source of protection. The project manager may be required to obtain approval before obligating or spending management reserves. Management reserves are not a part of the project cost baseline, but they are included in the overall project budget. Regardless of the type of reserve, some organizations have standards set for the amount of funds they allow as a buffer, as well as taking into consideration the type and level of risk. Cost of quality involves determining the costs associated with conforming to the quality requirements of the project. The last tool and technique I want to cover is vendor bid analysis. One way to estimate costs is to look at what the project should cost by obtaining and reviewing bids from qualified vendors. For example, you plan to buy 10 computers for the project, so you ask vendors to submit bids. The cost estimates you receive from the vendors can help you in developing a realistic cost estimate for the project. The key outputs in the estimate cost process are activity cost estimates and basis of estimates. Activity cost estimates are quantitative assessments of the probable costs required to complete project work. All of the activities to be completed on the project should have associated costs such as direct labor, materials, equipment, services, facilities, information technology, and special categories such as cost of financing and inflation allowance and exchange rates. These costs need to be identified and calculated for each activity. By basis of estimates, we mean those additional necessary details that support the cost estimate. We have to provide supporting documents that provide a clear and complete understanding of how the cost estimates were derived. The third process is determine budget. It is the process of aggregating the estimated costs of individual activities or work packages to establish an authorized cost baseline. We have just completed calculating the activity cost estimates, so now we can add them all up or aggregate them into work packages and roll them up to higher WBS levels. In other words, at the control account level and then all the way up to the total project level to establish an authorized cost baseline. This baseline will now be used to monitor and control project performance. Think about how accurate your budget will be by going through this detailed process. Amazing, isn't it? Let's now look at the key ITTOs for this process. Some of the key inputs for the determine budget process are as follows. Scope baseline, which includes the project scope statement, the WBS, and the WBS dictionary. Activity cost estimates are a key input in this process. The budget is really the aggregation of all the activity cost estimates. The more accurate we can be with the estimates, the more accurate the budget estimation will be. Basis of estimates. That is, the details that support the activity cost estimates. It's important for the individual developing the budget to understand the assumptions made and be able to review and understand the logic behind them. Project schedule is important here because it shows when the activities are scheduled and when money will be spent. Resource calendars show when resources will be available to work on the project, so we can allocate resource costs over the duration of the project. Risk register will help provide information about the risks we have identified on the project and how to aggregate the risk response costs. The key tool and technique we use in the determine budget process is cost aggregation. I mentioned this briefly before. In order to estimate overall project costs, you aggregate or add up the activity cost estimates for all activities or work packages to derive an approved cost baseline for the entire project. The technique we use to do this is called cost aggregation. Just imagine that this would be an aggravating and time-consuming effort. Reserve analysis, another tool and technique, can establish both the contingency reserves and the management reserves for the project. We discussed this earlier, but it's also a tool and technique in this process, so here's some additional information. The summation or aggregation of the activity cost estimates are added to the contingency reserve to give you your cost baseline for the project. The cost baseline is the one that is used for tracking and monitoring, including earned value management calculations. The cost baseline added to the management reserve is called the project budget. This is the maximum amount of money that the company commits to spend on the project. In this process, the activity cost estimates are added up or aggregated into work packages and rolled up to higher WBS levels, in other words, control accounts. And ultimately, they are rolled up all the way to the project cost level. The cost baseline, which is the key output for this process, is the approved version of the time phase project budget, excluding any management reserves, and it can be changed only through formal change control procedures and is used as a basis for comparison to actual results. Control costs is the process of monitoring the status of the project to update the project budget and managing changes to the cost baseline. Project cost control seeks to recognize variances from plan and then take any needed corrective action and minimize risk. Obviously, there are many aspects of the project that we need to control, such as scope, schedule, and quality, so this is just one piece of the puzzle. As you can imagine, project cost control is an involved process. It includes many activities, including but not limited to influencing the factors that create changes to the authorized cost baseline, ensuring that cost expenditures do not exceed the authorized funding by period, by WBS component, by activity, and in total for the project. Monitoring cost performance to isolate and understand variances from the approved cost baseline. Informing appropriate stakeholders of all the approved changes and associated costs. And finally, bringing expected cost overruns within acceptable limits. So with all of that in mind, let's meet in the next video to talk about the ITTOs for this fourth and final process of project cost management. The key inputs for the control cost process are the project management plan, which contains the cost management plan and cost baseline. The cost management plan provides guidance on how the project costs will be managed and controlled and what tools and strategies can be used to control costs. The cost baseline shows costs relative to time and how dollars will be spent or allocated as the schedule progresses. It will be helpful as we compare the cost baseline with the actual results to determine if any changes, corrective actions, or preventive actions are needed. Work performance data is about obtaining the status of deliverables such as which activities have started, finished, how much progress they've made, costs that have been authorized, and estimates for the future. All of this is needed to gauge project progress at a point in time. Here we have listed the key tools and techniques for the control cost process. Earned Value Management, abbreviated EVM, is a methodology that combines scope, schedule, and cost measurements to assess project performance and progress. It integrates the scope baseline with the cost baseline, along with the schedule baseline, to form the performance baseline, which helps the project management team assess and measure project performance and progress. Here are some key measurements that are computed for each work package and control account. The first, plan value. It's the value of the work that was planned to be completed by a date. Total PV, or plan value, for the project is called the budget at completion, or BAC. Earned value. It's the value of the work that was completed as of a date. Actual costs. It's the actual costs incurred for accomplishing the work performed as of a date. In other words, direct hours, direct costs, and all costs, including indirect costs. Now, based on the above measurements, the following variances can be computed. Schedule variance, or SV. This is the difference between earned value, EV, and planned value, PV. The formula is SV equals EV minus PV. The schedule variance is really the amount of work that has been done minus the value of the work planned. A positive number for schedule variance indicates that the project is moving ahead of planned schedule. A negative schedule variance indicates that the project is lagging behind the planned schedule. SV at the end of the project is 0. Cost variance, or CV. This is the difference between the earned value and the actual costs incurred. The formula is CV equals EV minus AC. A positive number for cost variance indicates that the project was able to complete more work for the money actually spent. So, under budget. While a negative number indicates that the value that was earned was less than what was planned. In other words, by spending the actual amount of money that was spent. CV at the end of the project is the difference between BAC and the actual amount spent. So, both of the above variances give an insight as to whether the project is over or under budget and over or under schedule. The reporting and analysis of the above measurements can also be done using some of these indices. Let's start with Schedule Performance Index. This is the ratio of earned value over planned value. SPI equals EV divided by PV. A ratio of greater than 1 indicates that the project is performing better than planned, schedule-wise, or more work completed than planned. And a ratio of less than 1 indicates that the value earned is less than what was planned for, so the schedule is lagging, or simply that less work was completed than planned. Cost Performance Index, CPI. This is the ratio of earned value over actual costs. CPI equals EV divided by AC. Here the ratio of greater than 1 indicates that there is more value earned by spending money than planned. And a ratio of less than 1 indicates that the value earned is less than what was planned by spending the money, or spending AC. Collectively, these values can be a great reporting and analysis tool to understand the pulse of the project, if it is within schedule as planned and within budget as planned. Note that a good rule of thumb to remember is that any calculation that results in a negative number or less than 1 is bad news. Forecasting. As the project progresses, the project team may develop a forecast for the estimate at completion, or EAC, that may differ from the budget at completion, or BAC, based on the project performance. If it becomes obvious that the BAC is no longer viable, the project manager should consider forecasting the EAC based on one of the following options. The first, the original estimating assumptions were not valid. If the original plan is no longer valid, due to assumptions we made, we will have to create a new estimate for the remaining work, referred to as Estimate to Complete, or ETC, and then take into account what has already been spent on the project. So the new forecast is calculated using the following. EAC equals AC plus ETC. Number 2, variances are atypical. In other words, EAC forecast for estimate to complete work performed at the budgeted rate. If current cost variances are not typical for the entire project and the remaining work is expected to be performed at the planned rate, then use EAC equals AC plus and then BAC minus EV. So we assume in this scenario that future performance will improve. 3, variances are typical. In other words, estimate at complete forecast for estimate to complete work performed at the present CPI. If current cost variance is typical for the entire project, then use this formula. EAC equals BAC divided by CPI. So we assume that what the project has experienced to date will be expected to continue in the future. One final note, from PMP exam perspective, if additional information is not provided, assume that variances are typical for calculating earned value. The To Complete Performance Index, or TCPI. This is the calculated projection of cost performance that must be achieved on the remaining work to meet the specified target, either BAC or EAC. It is the ratio of remaining work to the funds remaining. If TCPI is greater than 1, then there is more work to be done than funds available. If TCPI is less than 1, then we should be able to complete the project without using all the remaining budget. TCPI equals work remaining, BAC minus EV, divided by funds remaining, BAC minus AC. Or TCPI equals work remaining, BAC minus EV, divided by funds remaining, EAC minus AC. You would use this last formula if there is an approved EAC, or estimate at complete. The key outputs for control costs are work performance information and cost forecasts. For work performance information, again, let's take a look at this chart. We just went over the key performance values, and here they are. The cost variance, schedule variance, cost performance index, schedule performance index, to complete performance index, and variance at completion values for WBS components. In particular, the work packages and control accounts are documented and communicated to stakeholders. Referring to the same chart for cost forecast as an output, either a calculated estimate at completion value or bottom-up estimate at completion value is documented and communicated to stakeholders. Finally, we have change requests as an output. Once project performance is analyzed, it may result in the need to make some changes to the cost baseline or other components of the project management plan. Change requests may include preventive or corrective actions and are processed for review and disposition through the Perform Integrated Change Control process. And that completes this overview of the Project Cost Management knowledge area of PMBOK 5. It's a vast knowledge area, and I hope that you have a greater understanding and appreciation of all that goes into planning, determining, and controlling project costs. While you mull over the concepts you learned in this module, I'll be preparing to tell you next all about quality project management in the next module. Thanks for watching.